to this stream. This is going to be a good one. Today, we're doing math. Yes, we're doing math, and I'm really excited. This is going to be good. Hopefully, when some people drop by, we will start. I'm going to wait for people to show up. Doing math with no one here. It's just sad. Doing math with people here, now, that's slightly less boring and embarrassing. Yeah, if no one was here, that'd just be sad. I'm just going to get some water. I'll be right back. I'm very excited for this. Math stream is PogChamp. I think we're gonna start with some calculus. We're gonna do Calc 1, 2, and 3 easy. All of them, knock them straight down. It's gonna be simple. Easy, exactly. Calculus, it's a piece of cake. I'm gonna explain it easy enough for a 7th grader to understand. That's the goal, right? 6th grader is a little suspicious. Yeah, exactly. I am on 6th grader, like, right? 6th graders still don't know what a function is, and I think you got to know functions before calculus. I think that's a key part of it. I think 7th grader is borderline, right? 7th graders don't know how to FOIL, don't know how to factor, don't know how to might know how to distribute. You learn functions in 5th grade? I learned them in 7th grade. Factoring is easy. Factoring is like the hardest thing in 8th grade. Like the hardest thing. I think so. If I remember 8th grade at all, which I don't, to be fair. That was years and years ago. Logs are harder. I don't think I learned that in 8th grade. I think I learned that in maybe 10th grade. No, probably 9th. No, yeah. 9th grade was geometry. Who even knows? Anyway, I think you have to know a function. I think that's very key. And I think that you can get by in calculus without knowing how to FOIL or knowing how to factor. I think you can get by without either, especially with what I'm explaining. However, if we move into higher level math, they have no chance. Like really no chance. I'm serious about that. It's going to be really, really hard to get by without like being able to understand what a variable is in like a deep, deep level. And if you can't FOIL, it's going to be tough. It's going to be really tough. But maybe I'll just give them a deeper understanding of variables and they'll understand something. Anyway, we'll see. Hopefully some people will show up soon. You can factor without foiling. Yeah, but foiling's way easier. You might as well foil before you factor. Foiling is easiest thing in the world. I could explain foiling in 5 seconds and they'd all understand it. Factoring would take like what, 20 minutes? Like it just takes more time. But foiling is absolutely nothing. Anyway, we're doing calculus. That's what we're starting with. And I'm hoping it's easy. How's the font, and is it blurry? It kind of looks blurry to me. I don't know if it's also blurry for you. Teachers are watching this shaking. I'm about to teach their whole subject in half an hour. Three semesters in half an hour. Yeah, no, but I'm not teaching anything of nitty-gritty, and we're doing no examples, so. Anyway, start momentarily. Let's see. That should be fine. And I have this just to draw on because we need something to draw on. And let me see. Can I do this? Can I add fun things to? Oh, this is my beautiful art, by the way. It's called Abstract. I'm about to steal their job. Yeah, for sure. Let's erase this all. Bubble Poppin' Boys says I'm peeing. I don't want to know that. There's some next level stuff. I don't really care. Let's see. If I want to add a graph to this thing, if I copy the graph and then I paste the graph, it works? I never would have guessed in my life that would have worked. Okay. I don't know how to zoom out. And I don't know how to make that smaller. Whatever. Low-key better grab my little sister's homework and put it in the Discord to see if I can do it. I can. I'm pretty sure I can. All right. Let's start going through calculus, okay? All right. I know the Bubble Poppin' boys have taken calculus before, and I figured I should start with the definition of calculus, just because that seems like a good place to start. So, right, if I'm like calculus, the study of blank, and before I gave this talk, I was like, I should know what this is. I have a guess, but I think I know what this is, but I'm gonna look it up and make sure. And my guess was correct. Can you guys guess what this blank is? For someone who has taken calculus before, what is this blank? The study of blank. The surface area of a non-Euclidean object. I cannot teach you that. I have not taken topology yet, but I might. Give it a guess. Calculus is the study of blank. How things change. Change is correct. The study of change. The mathematical study, I should probably add. Mathematical study of change. The study of soiling your genes is not correct. But change is right. We're talking about how things change. That's what calculus is all about. All right? And calculus is built on three things. Three things guide all of calculus. Like, everything else in calculus is not considered really calculus. It's just kind of applications of these three ideas that carry calculus on their back. And two of the things are just applications of the first thing. So the first thing is everything. I'm going to teach you one thing, and that's what all of calculus is based on completely. You got an ad to join the Marines before joining the math stream. You know I'm about to join the Marines. Clearly that ad was placed well. Okay, so let's talk. The one thing that carries all of calculus on its back, and it's called the limit. Okay, the limit. The limit is the first important thing in calculus, and we're going to talk about the limit using an example. So let's talk about a line segment. We're going from point A to point B. Okay? Let's say you're at point A. You want to get to point B. And how this works is after every second, you get halfway there. And then after another half a second, you get another halfway there. And after another second, you get another halfway there. And after another second, you get another halfway there. You see what's happening? You're halfway, and then you're halfway of that halfway, and then you're halfway of that, and then that, and then halfway there, and then halfway there, right? And you actually never will make it to B. No matter how many seconds go by, even though you're getting closer, you're never quite actually making it to your final point. But you're clearly getting closer and closer and closer and closer. So this is where mathematicians bring in this idea of a limit. So what we're going to say is that the limit, as time goes on, as time goes to infinity, as that limit, the limit as time goes to infinity of this function or whatever is B. So what we're saying is, if you let time go infinitely long, you hit B. And notice this is a hard equal sign. This is not like you're about at B after infinite time. No. Because infinity is this insane concept that we don't understand, we're allowed to write an equal sign here. And it kind of seems like we're like fudging it a little bit because you never really get there. So we're like fudging this idea of we'll get there one day because we have infinite time. No. This is an equal sign, and we're gonna try and show that there's some rigor here. Yeah, the equal sign is PogChamp. So let's put some numbers here. Let's say you're on a number line. You're going from 0 to 1. As we said, the limit as you do this half thing infinite times, the limit here would equal 1. All right? Now, let's talk about it with a graph. Let's see if I can make a graph real quick. How fast can I do it? I don't know. We made a graph. So let's say now we want to go from 0 to 6. 6 is kind of complicated. Let's go from 0 to 4. Okay? So, right, like we said before, we're going to do the same strategy. We're going to get halfway there, then we're going to get halfway there, then we're going to get halfway there, ... I'm not going to talk about it with a rap. Okay, so first you go, so if we talk about like the distance traveled, we're hoping at the end is equal to 4, if like the limit as it approaches infinity. We're hoping the distance traveled is 4. So the distance, first we travel 2 units, then we travel 1 unit, then we travel a half, and then a quarter, and then plus ... But as we said earlier, the 1/2 plus 1/4 thing, the limit as n approaches infinity of this thing of 1/2 plus ... that was equal to 1. Right? That's what we said earlier. This 1/2 plus a quarter forever is equal to 1. So let's substitute that in. Because this is equal to 1, we can say the distance is equal to 2 plus 1 plus that whole thing, which is all equal to 1. And 2 plus 1 plus 1 is 4, and that's the distance that we actually travel with infinite time. So the idea of a limit has some rigor to it. It makes sense. If you start thinking about it more and more, it ends up actually like being a real mathematical idea that holds up. So let's talk about where this limit actually matters. Because, the limit matters a little bit, but let's talk about what really matters to the next two ideas of calculus. The derivative and the integral. This is everything. This is all of calculus, are these two things. Are we ready to cover these two things? Your teacher complicated the fuck out of this. Yeah, I mean, there is more complex stuff to go into. And if you're going to do examples, you have to go into it, right? Like if you're going to do actual problems, right? We're not doing any problems. But if we have to get into problems using limits and derivatives, I have to teach them more so they actually understand what's going on. But I'm saying like this is like the general idea of what's happening in calculus. All right, let's talk derivatives. Let's draw a random graph. Something. Yo, Snowy Owl. Is that bits? Oh my god, thanks for the bits, Snowy Owl. Appreciate it a lot. All right, let's draw a graph. It looks something like this. Okay, this is a graph of like y equals 4 minus x squared plus 4, something like that. It looks something like this graph does. Something like that. And now we're going to talk, the numbers don't actually matter. And we're going to talk about the derivative. So in like 7th grade or earlier, you learned what a function does. So let's draw a function like one you've seen before. Can I draw a line? It's possible. Yeah, that's about a line. It doesn't look that good. Let's draw a better line. Whew. That still doesn't look like a line. Man, I wish I could just draw a line. Nope. Nope. All right, I guess we're just drawing our best. I cannot. This is the hardest part of the whole thing. Okay, that's pretty solid. We've got a line. And one thing you were often asked is, what is the slope of this line? And how did we do that? We took 2 points, and we found the slope between them. So let's choose this point and this point. So this is the point 5, 1. And this is the point 0, -1. And to find the slope between these two things, right, you do the slope formula, which is y2 minus y1 over x2 minus x1. Familiar stuff. Man, college level math is going to be really next level hard. Okay, so and then you do 5 minus, wow, math is hard. You do 1 minus -1 over 5 minus 0. You end up with 2/5 as your slope. Okay, so we just found the slope of this linear line. Great. But now we want to find the slope of a nonlinear line. What do I mean? The slope is not a constant thing. Well, we're going to talk about the slope of this graph at this point. So how does this work? The graph, as you can see, you can imagine, like if I were to run my hand, if it was straight along the graph, it would like change slopes as we went. So like at this point, my hand would be facing like this. And at this point, my hand would be facing like this. And at this point, my hand would be facing kind of flat. Okay, these are called tangent lines, but that's not really important. We're just talking about at this point, what does the slope kind of look like? So the point of interest we said before was here. And what does the slope look like? Well, it looks like about maybe a little less than 1, but we're just going to say 1. It looks like the slope at that point is 1. What about the slope at this point? The slope at this point looks like, I don't know, -1/2. And the slope at this point looks like it's close to 0. So this is all of what a derivative is. A derivative uses a limit to try and find the slope at one point. Like if we were to zoom in on one point, what would the slope at that point be? Let's actually try and zoom in so we can show it better. So hopefully I can get a more exact brush. This is going to be bad, but whatever. All right, and then we start zooming in. Let's see if we can zoom in, because I don't actually know how to do that. No, that doesn't work. Okay, maybe we can't zoom in. Then we cry. Okay, that didn't work. All right, I failed. I failed everybody. Okay, so we can't zoom in, but usually we would do a little thing where we can zoom in and we can see as we get closer and closer, the line becomes more and more linear, and it looks like it's just a straight line. Anyway, so as we get zoom in and zoom in and zoom in. Oh, I was given a link. Let me open this link, see if it's anything useful. Math Meme Project 2016. I am not going to open that on stream right now because we're still in the middle of important thing. So derivative. So we're saying that the slope at a particular point has whoa. Wait, just a break for a second. What am I doing? This is so cool. What is happening? It looks like this is like the surface of water and I'm disturbing it a little bit. is going on? This is so much cooler than math. We'll get back to the math. What is happening right now? This is so cool. Just mess with the graph. Okay, sometimes you just need to fool around. All right, let's get back to the calculus. Let's get back. Clear. Paste. So we've got a brush, and we're drawing a graph. Looks like okay. Got a graph, and we're saying like at this point, we can say that the line has a sort of slope, and we can find the formula for that slope. Remember earlier, we said the slope between 2 points, like if we choose this point and this point, is y1 minus y2 over x1 minus x2. Then we find the slope of that line. Well, if we make this get much closer to this, then we can get the slope at like that instantaneous point. So let's do an example of that to show that. So we're going to start at 2 here. We're going to choose this point, and we're going to write out the slope formula. So we're going to start at x equals 5. So we wrote f of, that's 5, minus f of 2 over 5 minus 2. That makes sense? But as I said, right, we want to get this point really, really, really close to 2, so then we can see exactly what the slope would be at that instantaneous point. So we don't want a 5 here, and we don't want a 5 here. What we want is a number really close to 2. And if we're getting really, really close to something, that kind of sounds like our limit that we were talking about before. So let's pull out a limit. So we're starting at some point on the right side of 2, right? So this is 2 plus some little value h, whatever, some positive value h, so that we have a point to the right of 2. Then we're going to subtract f of 2, and then we're going to divide by 2 plus h minus 2. Again, this is the slope formula. And we can do a little simplifying here. 2 minus 2 is 0. But remember, we want to bring h really, really close to 0, because then 2 plus h will be really, really close to 2. So how we write this is the limit as h approaches 0 of f of 2 plus h minus f of 2 over h. And this is the derivative. What the hell is this stream? It's a math stream. I'm explaining math, calculus level math, but easy enough for young people to understand. So we just wrote out this big thing, and if you just showed up, it probably makes no sense. But if you didn't just show up, hopefully this made sense where this came from. So this is a derivative, and this will give you the slope at 2. Does that make any sense, or should I repeat that? Let's see if anyone responds. I'm happy to repeat it. Repeat the whole stream cap. Okay, let's go over this idea of a derivative one more time. So again, the first thing we went over So first thing we said, calculus is the mathematical study of change. We're talking about how things change. A limit is when you get really, really close to something. Like for example, right? Say you're going from 2 to 3, and you want to get from 2 to 3. 1 second. No, I don't really want to go into the whole idea of a limit again. Let's just assume that you know what a limit is, even though you don't. And it'll work out just fine. So we've got a graph of this function right here. Okay? And what we want to do is find the slope at this point. So if you've only dealt with slope in terms of linear things, well, buckle up, because now we're going to find the slope at a specific instantaneous point. And the slope at this point looks like it's just about, it's just like this. It's the slope of that line, which is like 3. That looks like it's just about the slope. Like if you kind of imagine drawing a straight line at that point, it would be somewhere close to 3. And the way to calculate it is to say this is x equals -3, right? This is the point -3, -2. And let's say we just want to find the slope between that point and this point, this straight line slope. We would use our slope formula, right? y2 minus y1 over x2 minus x1. Change in y over change in x. Rise over run. Give me 1 second. Okay, I'm back. So let's say we want to find the slope between these 2 points. So what we do is use the slope formula. We would do the y value is 0 minus -2 over the x values are -1 minus -3. And then if you do it out, that's 2 over 2. That's a slope of 1, which makes sense. This looks like a slope of 1. So hopefully that makes some sense. But what if we want to find the slope at exactly this point, and not between 2 points, but rather like right here, between a point and a point right next to it, so we know the slope at that one point? Well, we're going to use a limit to do this. First, we're going to say we're going to use our slope formula. So we just used f of -1 minus f of -3. I'll explain all this in a second. Over -1 minus -3. So what did I just write? I just wrote out the slope formula we just did, right? This is y1 minus y2 over x1 minus x2. I just wrote out exactly the thing we just did. This was 2 over 2 equals 1. We just did this. But now we're going to use this to write a formula for the slope at this instantaneous point. And how we're going to do that is we're going to bring this point really, really, really close to this point. And when I say really, really close, I mean we're going to use a limit. So we're going to say, as this point gets really, really close to this point, what is the slope? The way we're going to write this is we're going to leave this side of the equation the same, and we're going to leave this side of the equation the same. But now instead of using -1, we want to get closer. Remember, -1 is greater than -3. So we're going to say this is some value greater than -3, some -3 plus a little bit. And over here, we're going to say this is an x value greater than -3. -3 plus a little bit. Hazy Kool-Aid, we're going over a derivative. There's some complicated stuff going on here. Anyway, so let me get to the last point of this, which is that as we get closer and closer, these h values are going to get smaller and smaller, right? Before we were using an h value of 2. When h is 2, we have this formula. When h is 0, we have a problem here, but we want an h value really close to 0, like 0.00001. So what we're going to say is we're going to take the limit as h approaches 0 of this formula. And that will tell us the slope of this line at -3. And if you can understand what I'm saying at all, that's what calculus is built on. It's just this one idea of this instantaneous slope. Hopefully that made any sense to anyone in the stream. And again, I can repeat that because this is like the fundamental idea of the whole thing. Hope you're doing well, Z. All right. No one has said that they understood what I just said, so I'm happy to do it one more time. Should we go through it one more time? Let's do it one more time. Okay. So as we said before, a limit is getting closer and closer and closer to a number, but never quite getting there. Okay? That's like approaching infinity. You'll never hit infinity. That's not a number, but you can get closer and closer, and but never quite actually hitting infinity. And then the derivative is the instantaneous slope at a point, which we're going to go through one more time. So let's do a derivative again, one last time. So we're going to take our brush. We're going to paint a graph. All right. We're going to pick a point on this graph. Let's pick this point, 2, 0. And let's pick another point here. This is 6, 2. If I were to ask for the slope between these 2 points, we could use our handy-dandy slope formula that we learned in whatever, 7th grade or whatever. And we would say y2 minus y1 equals over x2 minus x1, right? Change in y over change in x. Everybody knows our slope formula. That would be 2 minus 0 over 6 minus 2. Then we get a slope of 1/2, because the slope of this line that I just drew is 1/2. Hopefully that makes sense. However, we don't want the slope of that line. We're asking, what is the slope of this line, the line going through that point of interest? We care about this point 2, 0. We want to know the slope at this point. And it looks like the slope is just about -1-ish, right? If you look at it, it kind of looks like it's -1, maybe a little bit less than -1, like maybe -2. I don't know. Let's keep going through it. So we want the slope at this point, and this slope is not a good approximation. But if we notice, if we bring this point closer, this 6, 2 point closer to 2, 0, say we pick this point, or we pick this point, or we pick this point, the slope gets closer and closer to the actual value that it is until we actually get this tangent line slope that we want. So what we want to do is we want to bring the slope formula to 2, but we never want to actually hit 2. You can't find the slope of the same point on itself. That doesn't give you anything. Then change in y would be 0, change in x would be 0. 0 over 0 is dividing by 0. That's a problem. Okay? But we can pick a point really, really close to 2, 0, and that's fine, as long as it's not the exact same point. So let's go over it. So we said our slope formula before was f of 6 minus f of 2 over 6 minus 2. This is the slope here that we just found is 1/2, right? This is y minus x over x minus x. F of 6 minus f of 2 over 6 minus 2. Hopefully that makes sense. But then we want to bring 6 closer to 2. So if we think about it, this is the same as f of 2 plus 4 minus f of 2 over 2 plus 4 minus 2. But what we want to do is we want to bring this 4 really, really close to 0 so that we can pick 2 points really, really close together. So in order to pick points close together, we want this to approach 0 is what we say. So we're going to write f of 2 plus some number h minus f of 2 over 2 plus h minus 2. And as we said before, we want this value of h to get really, really small so that we can get closer and closer to the point 2, 0. So these 2's cancel. 2 minus 2 is 0. So what we would write is the limit as h approaches 0 of f of 2 plus h minus f of 2 over h. This is our definition of a derivative. That's what a derivative is. I think I've gone over it enough times. Hopefully it makes some sense. As long as it makes some sense, then we can keep going. So I'll let it sink in just for a second. Okay, let's get into this derivative idea a little bit more. So now we're going to talk about the derivative as a function. So here's one graph. Can we put 2 graphs? Probably not. Okay, I'm going to have to do my own graphing thing here then. Let's get out of here. Now we're going to talk about the derivative as a function. So here's a graph. Okay, that's a nice graph. It's like a downward facing parabola with like a vertex here. And let's say we want to find the derivative, the slope at every point on this graph. At every point. Well, that is a tall order to find the derivative at every single point. Well, what if, right, this thing on the left is a function. Let's give it a name so it's not so scary. Let's call this, this is 4 minus x squared plus 4. That's this function. What we can do is we can find our own function that tells us the slope of this function at every point. Now that doesn't really make sense, but I'm going to slowly go into it. So let's find the slope of this function at every point. So let's pick a couple points to find. How about this one, and this one, this one, this one, and this one. So here, the slope is a positive number, maybe like 3. Here, the slope is another positive number, maybe like 1 or 2. Here, the slope at this exact point looks like it's just about 0. So we'll write 0. The slope at this point kind of looks like -1. And the slope at this point kind of looks like -3, -4, something like that, right? We're imagining a tangent line at each of these points. And now we can actually graph these slopes as our outputs to a function. So, right, input, this point right here is 4, 4. That's the vertex of our parabola. And we're saying it has a slope of 0. So what if over here we have our slope graph where we input the x value of a point and we output its slope value. So at x equals 4, we have a slope of 0, so y equals 0. And over here at x equals 5, we have -1 as our slope. So 5 comma -1 is a point on our slope graph. Over here at 3 comma 1, that doesn't really look like a 3, but just pretend like it is. At 3 comma 1, we have a point, so we'll draw that on our slope graph. And we can do the same thing, and we can find that our slope graph looks something like this. So this is now a graph that will tell you the slope of this graph at any point. If you want to know the slope at x equals 0 right here, well, you can go to x equals 0 right here, and you're like, the slope is 4. That's the instantaneous slope at 0 on this graph. So this graph tells you the slope of this graph. So suddenly that definition we wrote before might be better written in a different way. Let's rewrite the definition from before, because before we wrote it in terms of 2 and in terms of -3, right? We wrote f of 2 plus h. Well, what if we want this whole slope graph that will give us the slope at any point? Well, maybe we don't want this to be a 2. That's too specific. What if we just do an x? Then we can find it at any point. So let's rewrite that too. Let's erase what we have here. In order to find this slope graph, we're going to need to change our definition a little bit. And then we'll have the final definition of a derivative. This is probably going over all of your heads, but might as well try. So now instead of f of 2 plus h minus f of 2, we're going to do x plus h minus x, f of x. This will allow us to find the function that'll tell us the slope at any point, instead of just finding the slope at one point. This was over h. So this is the limit as h approaches 0 of this. And this is our derivative. It's all about finding slopes at specific points. Let's see if I can write this in a nice way that works math-wise. All right, well, hopefully that made any sense. And then we can move on to an integral. And if you missed everything what I said before, an integral is completely new. So you can still figure out what an integral is without knowing what a derivative is. So let's talk integrals. Integrals are all about area. And you know what area is. You can find the area of a triangle. You can find the area of a rectangle. Now we're going to find the area of, whoa, that shape. That's what an integral will help us do. So let's do that. Okay, so let's draw a graph. It looks like this. Okay, and let's say we want to find the area of this segment of the graph. Well, we can approximate the area using rectangles, right? If we draw a rectangle here, and then a rectangle here, and then a rectangle here, and then a rectangle here, and a rectangle here, and here, and here, we have 7 rectangles that will approximate the area under the curve from this point A to this point B. So these 7 rectangles, if we add up all the areas of these rectangles, we get almost the area of the under the curve from A to B. We miss out on these little excess areas that we don't actually get to cover, but we're pretty close. And one thing to make our approximation better is we can just make more rectangles. The more and more rectangles we make, we can actually see we get rid of some of the bad stuff. If we split all of our rectangles in half, now we get rid of a lot of the negative space. So now there's much and much less area we're missing out on. And if we make more and more rectangles, we can get even closer and closer to the actual area between A and B. And if we want more and more rectangles, we want like an insanely large amount of them so that we have a really accurate approximation. Well, that sounds like we can use a limit. So that's exactly how you find an integral. You use the limit as the amount of rectangles. So let's write it out. The limit as rectangles approach infinity. So as there are infinite rectangles of this function, we find the area. If we use infinitely many rectangles, we will have exactly the area under this curve. It's hard to think about, right? Like, I'm just saying you're using infinitely many rectangles, but how can you fit infinitely many rectangles in a finite space? That doesn't really make any sense. How can you, like, that doesn't, what? So the rectangles must have infinitesimal width. Like, their width must not even exist. And that's true. That's what calculus is all about. It's about an infinite number. Wow, I wrote im. It's about an infinite number of infinitesimally small things. That's what calculus is all about. And again, that kind of sounds like a loose, mathematicians are kind of making it up, but if you end up doing some research, it really becomes rigorous and it makes sense. So we have an infinite number of infinitesimally small rectangles, and they tell us the area under a curve. Now you're like, why? Why are we finding areas of graphs? Well, area is useful in its own right, but what's really, really powerful about, I should write out the definition of an integral. It's the area under a curve from a point to another using infinitely many rectangles that have infinitesimal width. Infinitesimal means really small. So how does this integral and this derivative help us? Well, this is the crazy fundamental theorem of calculus. How can the derivative and the integral be connected? Well, this one is bonkers, and I can't go through the whole derivation on stream. It just won't make any sense. But it turns out that the derivative of the integral of, let's say, f of x, some random function, let's say it looks like this, woo, right? Like we don't know what f of x looks like. It doesn't really matter. But the derivative of the integral of the function is just the function itself. What? Like, what? That's the same thing as saying f of x plus 1 minus 1 is just f of x. What we're saying is f of x times 3 divided by 3 is still f of x. We're saying that whatever the derivative does, the integral does the opposite so that f of x stays the same. How are we going to connect these two ideas of the continuous slope of a graph to the area under a graph. And that is too complicated for you guys to understand at this point. This is why you're going to take 3 semesters of calculus, so you can understand what's going on here. Even the day you do this, you won't understand what's going on here. It'll take weeks to understand what's happening. But derivatives and integrals are opposites. So let's write that down. Don't get rid of the screen. I'm copying notes for when you take calc next year. Nice. Yeah, at the beginning of calculus, you're going to do some limits, then you're going to do some derivatives, and then it's going to be a long time doing derivatives. And then you'll keep waiting, and then you'll get to integrals. And then the class will end. And you'll be like, I didn't get to think about integrals at all. But derivative, remember, is the slope at each point, and integrals are the area under the curve. And for some reason, they're inverses of each other. You'll find that out later. I believe there was more I had to talk about with these things. Give me one moment. Oh yeah, let's talk about some applications. Why are derivatives and integrals useful? Well, let's start with just a quick physics application. Let's say this is Henry, and he's got a ball in his hand. And here's Diamond, and Diamond's ready to do some catching. So the ball is going to travel to Diamond like that. This is Diamond. This is Henry. I throw a ball to you. Well, we can graph the ball's y position, right? This y position, its height, as a function of time. So let's graph height as a function of time. So when I throw it, it's almost on the ground. And that's at time t equals 0. Then I throw it up in the air, and it gets higher and higher and higher. Then it reaches its highest point, and then it gets lower and lower and lower until Diamond catches it. And Diamond is insanely tall, taller than me. So she catches it at this, or he catches it at this height. So this is the graph of the height of the ball over time. Well, it turns out if we can take the derivative of this, let's take the derivative, right? At this point, we find the slope is really positive, so it'd be like here, here-ish, and here the slope is basically 0, so that'd be here, and here the slope is really negative, so that's like here, and if we connect the dots, we find this is the slope of the line. So if we want the slope of the line here, well, we can just look right here. It's just about 2. So this is slope and the same time. And it turns out this is the crazy part, why derivatives are helpful. The slope of this line, this position graph, the slope of this line is equal to the velocity of the ball. Let me repeat that. When I let go of the ball, the amount it's changing its position by is the speed of the ball. Because that makes sense, right? Speed is distance over time. Distance over time. And if we change just a little bit of distance, right? Calculus is all about change. That's the fundamental idea. As we change just a little bit, that change in position over the change in time, that's exactly what slope is all about. This becomes a change in height over a change in time. And that's y over x. I'll say that one more time. So slope is change in y over change in x. Here, that's change in h over change in t. And we know the velocity is change in x over change in t, like change in position over change in time. No, Nick, it's not homework. We're doing fun math. They don't have to do homework yet because they're not actually taking the class. So it's just fun for now. If you don't have to do homework, it's still just learning, and learning is fun. You can quote me on that. I hope you're doing well, Nick. So as I just said, the derivative, the slope at any point on this graph, this position graph, gives you the velocity at that point. So that's one reason the derivative is helpful. It'll give you the speed of a ball. Bam. Immediate application. There are many, many applications. You'll do applications of changing areas. As like a sphere grows and shrinks, like what is its optimal, like holding capacity, stuff like that. Every single calculus person goes through the ladder problem, the classic ladder problem of a ladder is falling down a wall. How fast is it like moving down the wall, or how fast is it moving away from the wall? The classic ladder problem. Everyone in chat who's done a ladder problem knows what I'm talking about. You'll do like water comes into a tank and water leaves a tank, and you'll talk about how much water is in the tank. No, I cannot do a stream on LinkedIn. I'm not gonna do that. I also don't have a LinkedIn, so not a chance. So there's calculus. We just did really all I wanted to cover in Calc 1. Good thing there are 3 semesters of calculus. So now that Calc 1 is done, took an hour, we finished all of Calc 1. Let's write one application is that the derivative of position, is velocity. So we finished Calc 1. We have options now. We can do Calc 2. Okay? That would be like the next logical thing. Or we're tired of math and we can move to video games and come back to math another day. Those are the options. Calc 2, I don't have much to say. Calc 2 will be like 15 minutes. And then Calc 3 should be like 10 minutes. Because I really can't go very deep into them just because none of us have taken calculus. None of you guys have taken calculus. You just won't understand what's going on. But I can talk a little bit about Calc 2 and a little bit about Calc 3. And then we'll be done. Man, going into upper level math, I don't know if we can ever do that. Like, I really want to, because it's really, really interesting, and I find it way more interesting than calculus. Oh man, though, it is hard to understand. There's here, let me talk about upper level math just for a moment. So I'm a math major at college. That means I take a lot of theoretical math classes where we talk about theory of mathematics. And it's really, really interesting to me that the prerequisite to taking theoretical math classes at our school, you have to take Calc 3 before you can take theoretical math classes, which is interesting because after taking theoretical math, there is no calculus anywhere in there, not Calc 1, 2, or 3. Yet you still have to take all 3 before you can take theoretical math. And the reason that they told us of why they do that is called mathematical maturity. Because, oh man, you are not ready for theoretical math until you've taken Calc 3, just because you don't understand you have to understand every single fundamental idea of math and be able to apply them really quickly and understand what's going on. And calculus, just helps you reinforce the math skills you already have, plus teaches you new things. And other than the new things, they really care that you've reinforced those tools that you have to know in order to get through theoretical math. Thanks for coming, Diamond. Have a great day. So theoretical math is crazy hard. They say you have to have mathematical maturity. And, man, people in 7th grade, 8th grade don't have mathematical maturity. I mean, I could do my best, but you will get lost every other 10 seconds because you'll forget what a variable is. But one day I'm going to try anyway. Gotta try. All right, I'm going to run a poll. We're going to see, are we going to do Calc 2? Or are we going to do... Whoa, a thing. Someone followed. Thanks for the follow. Duda Kai Zeta? Something like that. All right, poll. What we doing next? There's Calc 2 or video games. I don't know what video games entails yet, but we'll just do whatever people want to do. I'm guessing, here's my guess, it's going to be 0-0. Oh, no. We already got a vote for video games. 2 video games. All right, we're probably going to do video games. That sounds good to me. I would love a break. We'll come back to more calc another day. Let's delete this thing. And we'll save this and do Calc 2 another day. Cool. We're playing video games. Let's do it. So what games do people want to watch? I can play Mario 35. I can play Smash. I can play Mario Maker. Anything is fine with me. Mario Maker 2? Sure. All right, I'll pull up Mario Maker 2. Sound good? Give me a moment. Let me make a transition here. I gotta move some things around. I'm gone. Okay. Okay, we'll boot up Mario Maker. Whoa. Anyway, I don't know if any of that made any sense, but we'll see. Playing Mario Maker viewer levels. So let's add that to the title. Mario Maker 2 viewer levels. I don't feel like setting up the whole warp world thing, so we'll do what we always do. Okay, that's good enough. I've updated Mario Maker. Now I need to move some things around. Gotta plug in the switch like that. I was last playing Odyssey. Cool. This one. Cool. So we're playing Mario Maker. All right, what level are we playing? I'm thinking just Icicle Gauntlet until people join. That sound good? People stealing my world records? Someone stole my world record. How could they? They don't understand. It's mine. Spike slide. Someone took the world record. Oh, snap. All right, let's steal it back. Can't let them have it. Can you guys not see it? Oh, you guys can't see it. Well, that matters. Okay. Well, let's see why not. I gotta do this and then this. Hey, there we go. Okay, let's do it. Someone stole my world record in Spike Slide, so I'm taking it back. I forgot how to move, so I'm gonna have to get better at moving again. Oh, I spun a little too early. Yep. Jumped a little too late. I should probably have a way to like do that consistently, but that's too much work. Okay, good start. Now I have to get the wall jump. Let's do this. I did the wall jump. So this is the opportunity. Oh, that was a pretty good. Oh, I thought that was a pretty well timed spin jump, but it was a little bit too early, late. It was little too late. Just barely. Okay, good start. We gotta hit the wall jump. Hardest part of the level after the actual hard jump. Right here. It's gonna be close. Yeah, we didn't make it. That makes sense. Wow, I don't think I've ever done that before. Just hit the side of the block. That's a bonking pro, as previously mentioned. Nobody can bonk like I can. Alright, this is it. This is world record. Just gonna focus and get it. World record incoming. As long as we hit the wall jump. The wall jump's kind of luck, because I have no idea how to do it right. Yeah, we hit the wall jump, so it's... Oh no. I think it was... Oh! Oh! Please don't screw it up, Henry! Let's go! World record! World record all day. I don't know if the pipe wall jump was faster than just running. If I performed it not well enough, where it was actually just faster to run. But we did it. So we take that all day. World record, let's see. This is not a world record pog. Indeed. Let's see, what records do we have and what do we not? We got the world record there. We have tied world record there. We don't have world record here. Someone stole this away from me? That's what they thought. They don't even know. Okay, it's been a while. We're gonna have to actually play well. Okay, that was cheese. And not record. Oh, it actually was really close to record. Oh, wait. I don't know if it's record or not. It's really close. Oh, we got there. All right, let's try and do the cheese record again. Oh, I just barely mistimed it. Toadette's schmoovin'. Oh my god. That is way harder to do than what I did before. There we go. That's a good world record. Smooth. That was awesome. Smooth. They think they're stealing my levels, stealing my records. They're not. Someone stole my wall jump canyon record. No, they didn't. No, they didn't. Okay. Gotta remember what the level looks like. You're kidding! I think it's faster to wall jump anyway, so I'll just wall jump next time. I wonder if that would have been record. I don't think so, but I didn't look. Ooh. Unlucky. Yeah, just a little late on the thing. On the propeller spin. Hey, that's record. Easy. Easy record. Takes no effort. Let's make it a little bit better, too. Let's get sub 8. Might as well. While we're here, we'll just nab the sub 8. Right after a world record. It takes nothing. Oh, I still bonked. Doesn't matter though. Still sub 8. Sub 7 possible? No, that was barely sub 8. Hey, but sub 8, we take it. Beekeeper's Mansion. Someone took Beekeeper's Mansion back? Dude, me and this Yoshi guy going back and forth. I thought my Beekeeper's Mansion record was good. They took it back. Strong start. Wow. I can't believe someone took Beekeeper's Mansion. It's actually shocking to me. Izzy Kool-Aid, your records are in hot contention. I will be the one to take it back. Nice. It's exactly the kind of start you want. Beautiful. Lots of smooth pipe entries. Everything is looking good up to this point. That pipe entry is so hard, and this jump is hard too. Yeah, that jump is really hard. That was a great start, though. Out of this Yoshi guy and me competing for your world records, personally, I'm rooting for me. I'm kind of just on the my side, you know? Nice. Probably should roll there. Probably doesn't matter. That's definitely faster. Ooh, that wall jump saves a little bit of time. Ooh, look at that. Optimization. Okay, I did the roll there. I'm actually the rolling god. Oh, that wall jump's a little bit harder than I thought. There's a ceiling, but it's fine. I mean, it all comes down to that one jump after the checkpoint, right? After CP2, you gotta make sure you get the jump into the clear pipe, and then the jump after the clear pipe. Those are by far the two hardest parts of the level, I think. That's what I would say, at least. Not quite, not quite. Nice, good rolls. Good rolls. Good rolls. Oh my god, so many rolls. We're just rolling everywhere. Okay, that was not optimal, but it was fine. No! That's okay, that's okay, that's okay. 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 Good. 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 Okay. This is all going smoothly. Okay, that was not the smoothest clear pipe entry, but it was fine. Here's the hard jump. Oh, that was sick! Please, please, please. World record, please. Maybe? I think we got it. I think we got it by 2 seconds, actually. I think we got it easy mode. Oh, it's too easy, dude. World record all day. That was easy. Mecha Madness, he stole our world record too? Dude, this Yoshi guy is killing me. Oh yeah, we had the clutch, Z. We had the ultimate clutch. Wow, you are way behind with delay. Like, so far behind. It is crazy. Nice. Oh. Dang. Not quite, not quite. Okay, so I've overshot like every jump by just a little bit so far. Let's see if I can still get world record. Probably not, I would think. That was pretty good. That was pretty good. I mean, that was a really good run. If he still has a record better than me, then he's got a great record. Wow, he's still like half a second better. You could probably skip the second bounce on the first thwomp. Ooh, is that how I save half a second? Let's skip the second bounce on the first thwomp and see what happens. Oh, yeah, we totally can. That saves half a second for sure. You'll have to watch the VOD for the math stream. Yeah, math stream went well, I think. It's really the viewers would know if it went well, if they understood any of what I was saying. But I mean, we did it. It happened. We talked about derivatives and integrals and limits. And we finished up Calc 1 as a whole with some applications. But I think ultimately probably went over everybody's heads. That's my guess. I'm realizing 290 is going to be impossible, bro. It's going to be impossible. Like, it's never going to happen. But I mean, I got to try. I'm just too interested in it that I need to share it, and I got to try. Calc 1 in an hour. Yeah, easy. You think the math stream was good, and you're starting geometry after holiday break. Wonderful. Geometry, you start doing proofs, and wow, did I hate geometry. I was like, why am I doing all this writing in math class? Okay? Little did I know that proofs are actually super awesome. Just in geometry, they're garbage. Geometry proofs make me want to shoot my brains out. But proofs in high-level math are super cool. Don't let geometry kill your love of proofs that may exist deep down. Because I almost did. That would have been the biggest misplay ever. Calc 1 in an hour. Super easy. And I had to explain a derivative 3 times, and I still did Calc 1 in an hour. Easy money. Wow, this is really tight. Trying to get this world record, but I bet this is way faster. I mean, it is way faster. We know it's faster. I just gotta hold Z right here, and then I should be able to just barely clip it right there. Oh, I was close. I was definitely close. But that's exactly where you have to hit the bullet bill. You just gotta be there a little bit later. We gotta stall a bit more. Yeah, I didn't stall enough. May I make another low gravity level today? Cool. I'm a big low gravity fan. Moving in low gravity is just fun. I'm a big Moon Kingdom fan in Super Mario Odyssey for similar reasons. It's just fun. You can really think about your movements as you do them. Unlike a melee player. Heyo. I've been playing a lot of online melee while I'm bored recently. Okay, this is world record pace for sure. Yeah. I didn't get world record by half a second. And then I learned about this exploit, which probably saves a little bit more than half a second. So, if we can do this... Oh, that definitely won't work. If we can do this, it's probably a world record. Yeah, I love the new skip. Whenever there's a new speedrunning skip, that's always a win. Makes a level way more cool. This is called Thwomp Skip, as we all know. Okay, that should be good. Thwomp Skip. Thwomp Skip is so good. I shouldn't even... Why am I even going for the checkpoint? I mean, we all know I have to land on that little thing. But, like, why do I even go for the checkpoint in general? Absolutely no reason for me to grab it. Oh. This is super world record pace. Like, super duper world record pace. This part's an auto-scroller, so it doesn't matter how much I optimize it. Well, it matters if I do that, but whatever. That's a choke sandwich with extra choke. I forgot Mecha Koopa Skip. Thwomp Skip. Wow. Choke sandwich. That was it. That was the record. And I threw it all away. Smooth. Thwomp Skip into bullet clip. Yeah, bullet clip is a good way to put it. You're just barely clipping the edge of the bullet. I mean, you're not actually clipping into the bullet, which is usually what clip is used for, but like it's good enough. Thwomp Skip, bullet clip. If you can do both, saves about half a second. Clearly worth it. That's always the funniest in like speedrunning videos. Like, this trick saves about 1/10 of a second, and if you fail it, it loses about 3 minutes. So it's clearly worth it to use in world record runs. Like, wow. These people are good at this game. Where it's worth going for. I missed bullet clip. So sad. Yeah. I found out there's a way I can run predictions on Twitch. Predictions are fun. They seem really fun. The ones where you can bet your channel points, and then you either win channel points or lose channel points if you get it right or you get it wrong. So I could be like, will I get world record in the next 5 minutes? And if you guess right, then you get points. And if you guess wrong, you lose your points. That seems really fun. Anyway, so I might start doing that more often. We could test a prediction now. Let's see. All right, at 35, I'll run the prediction. Will I get world record in the next 5 minutes? And then you guys can vote. I'll run it now. Let's see. Let's see how to do this so I can get better at it. start a prediction. Will Henry get world record by X41? Yes, no. The betting would be way more fun in Smash. I will need a mod to confirm the outcome of the prediction. Okay, well, yeah, betting would be fun in Smash. Anyway, so if you want, you can bet, but you don't have to. You can bet on either I will get world record or I won't get world record. So bet whatever you want. Let's see what the predictions are. Yeah, streamers cannot. Oh, mods can't cast a prediction either. Oh, snap. Get destroyed, Nate. Nate can't predict. What a nerd. Stupid mod. Okay, so all of the predictions are for yes. Oh, so that's actually really bad. Because then you don't win anything if you're right. And you lose if you're wrong. So it's actually useless. Oh, okay, so I should cancel this prediction. Can we cancel it? No, we'll just agree that it's yes after the thing ends. So that Zcooley doesn't lose points for no reason. Hey, but we're learning how it works. So it only works if there are at least 2 people voting on it. It's a good start. And they vote in different directions. The betting would be really fun in Smash. The answer is going to be yes anyway. So. Bullet clip, bullet clip. Heyo. There's a really, really high bounce afterwards. So losing time. But we're still going to get world record if we can just finish the level, I think. As long as we play like pretty well. Okay. There we go. That'll definitely be bullet clip. So we got another run going. And that was a good bounce afterwards, too. Okay. Everything's fine. Oh, so close. Okay, that'll definitely be bullet clip. We got another run going. Dang. Sad. Sag, indeed. I like the optimism, by the way. Voting for yes is way cooler than voting no. It's way more fun for me. Because then, like, I got stuff to play for, and basically rooting for me in my stream. You know, it's just generally a good idea. Unless Keishan's here. Then he'll make fun of you. Oh, I just barely hit that spike. Yeah, the betting would be really fun in Smash. Dang. Hi, Nugukaza. I will jump to your level very momentarily. I hope you're doing wonderfully. I will, we'll go to your level within, we'll say within 3 minutes. Right now there's a prediction running. Will I get world record on this level? within the next 2 minutes. And this is not the run, but we'll see if I can get it. So it's about like 3 more good tries, and then the prediction will be over. So hopefully I can get world record. Okay, that should be good. Oh, what? That was really close. Okay. All right, I got like 2 more good attempts in me. So hopefully they go well. It's going to be close. Bullet clip? We got bullet clip. Okay. That's the hardest part of the run. Oh. All right, this is it. Last run, last run, last run. Let's just get it. First try. I almost failed in the first Mecha Koopa. I almost failed there, too. It's going to be really close for bullet clip. Oh, my God. Okay, this is still... could be the run. I pressed Z. Okay, so now let's end the prediction and see what happens. Choose a prediction outcome. The answer is yes, I totally got world record. Great. Oh yeah, you get 50 channel points for getting it right. So I totally got world record, and you get channel points for that. Z Kool-Aid, congratulations. Let's play Nugu Kaza's level. CPN D67 S5G. Apparently, Nate has to validate that. Who knows? Galoomba Convention, no plays. But it's all about the P-Balloon. Let's do this. Reach the goal without taking damage. There are lots of P-Balloons and lots of Galoombas. I need to not take damage. What did I just... Oh, I killed a Galoomba. Okay, wait. So let's hit these. Maybe they can help me. Okay, those didn't help me. Is that our goal? Just to go really fast? That's what I'm thinking, right? Okay, there's a Yoshi. But I still think we just gotta go fast. Anybody else have any other ideas? I think it's just a go fast level. Hope we make it. Anybody else? Other ideas? Possibly. Wow. That Galoomba always seems to get me, though. I feel like that Galoomba is always there. Wow, they hit me? My hitbox is so chonkin' big. It's huge. This is an insane level. Oh, that was my chance. I had to angle a little down there at the end. I can't input jump, dude. I'm so bad. Tried to angle down at the end there, but I hadn't made it past the Galoomba before. Seems like there's a lot of luck here. Anybody else thinking that? Like, that one was destined to fail. Look at this clip. Someone sent me a clip. Unfortunately, Christian Productions, I'm not just gonna look at a clip on stream just randomly from a random viewer, because that could be dangerous and I could open bad things. You also didn't even send a clip, so that's beside the point. But I can't just click on a clip on stream. I mean, I could click on it off stream, or I could mute myself and look at it. But I'm not just gonna look at the clip, just willy-nilly. Because who knows what it could be? Who knows? Maybe I wanna use that spring that's there. Anybody else seeing the spring? Anybody else seeing all those tracks? Maybe it's like a weight level. See all these good things coming my way? Is it just a weight level? I don't know if it's just a weight level or not. Nugu Kaza, you want to save us some time? Is this just like a wait 300 seconds level? Is there a strategy that I'm not seeing? Can you go through a pipe? Use Galumba at the arrow before he wakes up. Oh, that one. Okay. Ooh, that's cool. Oh, I got hit by the thing. So I got hit. So the spring is there to like... Oh. Wait, no, I can't hit him. When I run into him, I get hurt. Right? When I run into that Galumba, I get hurt. Am I wrong? When I pee balloon into it, I get hurt. So should I not pee balloon into it? Should I get to it in some other way? Oh, it's that? Okay. Okay, so he takes a second after he hits the spring to be actually fully knocked down. So we gotta wait a sec. I got crushed? How did I even do that? Wow. Wow, I got crushed by the spring. Oh my god, that was so cool. We almost made it. That would have been hype. Okay, so it seems like there's some luck whether he'll be at the bottom or whether a different Galumba will be at the bottom. So we'll have to hope that the right Galumba comes down and not, you know, a Galumba that can hit me. Like, unfortunately, this time it was a Galumba. Oh, wait. Yeah, see, that's a Galumba that can hit me versus the other one. So there's some luck, but as long as he comes down, we should have a chance. I didn't mean to zoom up there. Alright, let's see what we can do. Ah. Oh, that one was possible but hard. Okay, this is a hard level. Yeah, that Galumba just got in my way. Wasn't possible that time. See, this is how am I supposed to do it this time? All the wrong Galumbas are here. Oh, whoa, wait, there are multiple Galumbas? There are multiple Galumbas that work. I see, there are 2 Galumbas. So this one's good too. But that Galumba's good. Why did I get hit? There are multiple Goomba. Every Goomba... Looks like there are 3 of them. Okay, let's use this one. It's the safest. Oh my god, that was going so well. Okay, yeah, he's here again. So maybe if you don't move, he always comes here. Close. Really close. Okay, so we need to not move. Have our boy come down bottom left. And then use him. Use the homie Galoomba to win. Oh my god. It's still hard though. Oh man. Just didn't kill enough things for me. Okay. Oh my god, I got really far, but not far enough. Whoo. That was a new record. No, he got out of the way again. He went out of the way again. So if I run to the right, will all the Galoombas come to the right except for him? Not even really, but it's our best shot. Aw, we bonked. Bonking pro, you know me. I did not mean to do that, obviously. Nice, okay. No, we bonked. It's fine? Oh my god. Wow. That was also a new PB. Please make it down. He didn't make it down. Okay, so we're fucked. Yep. That's how it goes. Sometimes you get unlucky. We're hoping our man makes it to the bottom. And he does not. Great. Let's do this. I've never seen a level like this. This is very unique. This is cool. You have to like follow the path you create for yourself using the Galoomba. Yeah. Hello, Pedguin Army 122. How are you doing today? I hope you're doing wonderfully. This is right now the only level I have in the queue. Is the one I'm playing right now. And it's difficult. List. Yeah, this is all we got. It's just this one. So if you'd like to submit a level, I will jump to it once I beat this one. This level's really cool. Okay, hoping the Galoomba makes it. Oh, he didn't make it. This run is impossible. Nice. Man, sometimes it feels impossible. Thanks for the level. I will jump to that one after this one. PRQ. That sounds familiar. I don't know why. I feel like I've seen a lot of levels that start with PRQ. Oh, I just missed. I will play that level after this one. Nice. I am not very good with the pea balloon. No, don't go in his way. Yes, the homie Galoomba. Man. It's really hard. I can't tell how many times I want to hit him. I feel like I want to hit him 3 times. And then I want... Nice. I feel like I want to hit him 3 times. And then I want to let him go. Okay, hit him 3 times. And then I let him go. And then I hit him again. I think I have to hit him 3 times, then wait a little bit, and then hit him 2 more times. Not really sure. Still getting used to it. Let's hit him 3 times again. Practice with that. Oh, I missed 3. Okay, let's just go for it. Yeah. Can't just go for it. Gotta have a strategy here. No, don't get in his way, you nerd. The run is dead. You want to stay directly behind him, even though the urge is to hit him a bit from below. Okay, we'll try and stay directly behind him. I was in front of him, which is exactly where the living Galoombas are. So that was not smart of me in that attempt. No! Yes! Our guy. So strong. He's got gravity on his side, so that helps. No, I went too fast. I knew I went too fast, too. Yeah, the Galoombas come up from the bottom, so that makes sense. You have to stay right by his side. Oh, let's go. Oh, GG. That was a really, really cool level. I've never seen anything like that. That was awesome. First clear. Let's go. GG, man. GG. That really take me 80 attempts? Has no one else tried this? Oh, no. Other people have tried it. Okay. Yeah. All right, so we're good. Oh my god, there's a Ninja right now? Okay, I might do the Ninja after Penguin's level. But hey, great level. Let's do a level from Penguin Army. Oh, I can't read. Let's do it. It is called Death Sentence. Spelled wrong. Death Sentence. Mel? Don't. Alright, let's try this. Penguin. I don't know what I'm doing, but I'm certainly doing it. Ah! No, no block. Oh, I thought that was a no block. Oh. Okay. So telling me to hurt myself and then come back. So I gotta go back and hurt myself? Interesting. The goal of this level is to die? What? I see soft lock. Yep, soft lock indeed. The goal of the level is to die. That's interesting. Reminds me of like an avoid the mushroom kind of level. Yeah, it's a soft lock. Yeah. But I see what I'm supposed to do now. Right, so if I die right now, then I can use that weird checkpoint placement to put me in a good spot. I see. So I want to die. However, these fire bars can't hit me, and these spikes can't hit me, and neither can this one. That spike over there can hit me, but actually only if I'm big. So that can hit me still. It's not a soft lock. Doesn't matter. Yeah, it is. What's your argument? Certainly looked like a soft lock from before, but I'm not sure. It was a soft lock as soon as I fell in the hole. That's what we're saying. If I hadn't fallen in the hole, once I fell in the hole as Big Mario, then I was soft locked. That was a great level. That was really unique. That was cool. Nice. Yeah. If you fall in the hole as Big Mario, you're soft locked. But if you're smart and you aren't Big Mario, then you're fine. Only an idiot would do that to themselves. All right, let's nab this world record real fast. And then I realized there's a ninja, and you know I'm about to give that an attempt. And I gotta try. I haven't done a ninja in forever. I need that checkpoint, don't I? How fast? Oh, wow, that can't hit me. Let's give it a shot. Close, but not quite. You can cheese this? How do I cheese it? But it needs timing. Okay, where's the cheese? Where's the spicy Gouda? Need to be Big Mario. Okay. And then when you're Big Mario, where's the cheese? I know I didn't take the checkpoint. That's okay, though. Is a P-switch going off right now? Yes, it is. I see. Okay. Yeah. That's definitely the fastest way. Okay, we're going to nab that world record. I'm going to have to turn up the volume, so you guys might hear double volume. But I got to do it for the world record. You guys understand. I got to turn it up. So the goal is to get to the P-switch as fast as possible. Okay, let's see what the time is, even though clearly this is not that fast. Okay. So we want to hurt ourselves on the spike on the right while we're waiting. Okay. There's also a dev, of course. Yeah, what's the dev exit? Is this the dev exit? No, this can't be the dev exit. No, I needed to break the other ones first. What's the dev path? Is it just like wait for a while? Hidden P-switch at the end of the level. Gotcha. Yeah, that makes sense. Okay, so let's do this. Okay, that was good. Oh, I think that's world record. You know the weird ceiling pattern with the bricks and the P blocks? Oh yeah. One of them has a hidden P switch. Let's see. Let's see if I can find the. I mean, obviously I wouldn't need the checkpoint if I were to use the other thing. Yeah, I see the door. The weird ceiling. Let's see, where's the weird ceiling? I wonder if it's faster or slower. There are those blocks for the P-switch. Ah, I see. So you hit the P-switch. You hit the P-switch and you just go up here and die. Okay, but we still have world record. They can't take that away. Yeah, world record. Love to see it. You thought someone got it with the dev exit? But it was because of the cheese. Goombud Bust Up. Oh, I've heard of this. I watched Panga play this, of course. It looked hard and jank and weird. And I didn't like it. And then I believe he shot one, kept running. I hit exit course. Let's do our best, just with some ninjas. I have a 4-3, 43, but there's 2 sections that are really hard. You have a 43, but there's 2 sections that are really hard? I'm not sure I understand. I didn't kill the first Goombud. I missed the first one. Dang. I hit exit course. Gosh. Okay. Let's try this again, where I actually kill the first Goombud. That worked, I guess. That was a weird way to do it, but it worked. Come over here, Thwamp. Nerd. Wow, this clown car just got blocked. No. Alright, whatever. I'll just do it with fireballs. Okay, we'll do it with Yosh. Blowy Joeys. Nice. 57 seconds. PB. I'm out of water. I'll be right back. Top 6,000 in the world. Pog you. Let's do better. Now we get to see all the ninjas. We're ahead of all of them. Look at us. There's one that's tied with us. Hey, pretty good start. Okay, we're in first out of all the ninjas we see. Oh no, we missed one. Now we're not in first of all the ninjas. Yo, I got a thing. I will look at the thing momentarily. I missed one. No! Atlanta, thanks for the follow. I'm doing some ninja racing, and then I'll join, and then I'll do your level. Basically right now, because this is the worst run ever. Alright, we're gonna play Atlanta's level right after this. Okay, we're playing Atlanta's level. Let's do it. SF3RPHQ3G. TTT, the Treaded Tram Transportation. Cause a train wreck for this tram. Seems like this level has some cool theming going on. It's a multiplayer versus. Crazy. Alright, let's do this. This is a hectic start for multiplayer versus. Oh snap. This is cool. This is super cool. Wow. This is super cool. I'm definitely taking a world record, by the way. If you think I'm not, you're crazy. Oh, that was a crazy early pipe entry. Aw, can't just run off. Doesn't just kind of work. Maybe you can run off holding Z, and it works. I'll try that. I can't hold Z for the whole level though. I should probably beat the level before I try for world record on it. Make more sense. Yeah, holding Z doesn't work. Okay, all right. Let's get the world record. Or let's just beat the level, and then we'll get world record. I just keep dying. Love lowering the clear rate. You're welcome. I'm sure that's what you want. I have to put this down. Oh, that's how the mechanism works. That's cool. Okay, I'm gonna pay more attention. I just keep kind of running into the level, like head first, and hoping it just works. Now I'm gonna like actually pay attention and try and beat the level and not be dumb about it. New stuff. I can go up here? No, I cannot. Let's just go in the pipe. Hey, that's it. Wow, I died so many unnecessary times. Great level. GG. Lots of cool theming. Now we're going to take the world record. That's the plan. Nice. It's a fine start. Could be better, but that's pretty good. I don't know the best way to go about that, so I just kind of hope that's good. Let's see, that was a 488 pipe entry. I have no idea how optimized this world record is, but it's going to be pretty optimized when we take it. Heyo. Oh, I thought I hit the jump input. That's a really hard jump input to get that just in time. Wow. You can really enter that earlier than you think you can. That's probably the best way to do it. 489. Nice. Might still be world record. I have no idea how optimized it is. Let's see. Okay, we gotta try and hit this. This is the hard part. Oh my god, that jump input is so hard. I should probably just take my time and see how optimized the world record is before going balls to the wall. Yeah, we'll see what I feel like though when I get there. The way I'm doing that, by the way, is I'm slowing myself down so that the Goombas line up. Normally I'm not lined up, but I'm slowing myself down so that they do line up, because I think that's faster than trying to go full speed and then slowing down in a weird way. Like trying to go full speed through the Goombas will not work. I think I'm just gonna die if I try and do that. So I'm slowing myself down just a little bit so that the Goombas line up easier, and then the whole thing just kind of works. And the time I'm losing from slowing down is probably minuscule. That's what I'm thinking. This level is not meant to be speedrun. It's a beautiful, beautiful level that has really nice theming. But this is what I do. And you know we're gonna take it. Shouldn't have jumped. There was no reason for me to jump. Not the best start, but fine. Didn't slow down enough. Good start. Still didn't slow down. Wow, you do have to slow down a lot. But I'm still gonna do it. Maybe it's faster to do... Ooh, here's a crazy strat. You go full speed, but right after the platform ends, you already have downwards momentum. Let me see if I can show you. Yeah, something like that is exactly what I meant, actually. That was pretty cool. Kind of just fall at the right time so it works. That's exactly what I was thinking. And I just kind of hit it first try. Go. Okay. Nice. Okay, we're gonna not do full speed. Just gonna do like half speed. We couldn't even go full speed because of the fire bar. That's what I figured. All right, that's easy world. Wow, that's a 6-second world record. Smooth. Great level. Really, really awesome. I enjoyed it a lot. All right, I'm willing to play one more level from chat, and then I'm gonna call the stream. So if someone has a level, I'm happy to play it. But after that, probably call it. Thanks for the level, Atlanta. GG. Come, Thwomp. Oh, no. Oh, no. Oh, no. Oh, no. Okay, this run is dead. Not the smoothest start. There are probably smoother ways to start it that I've done before, but whatever. Please, Thwomp. Good. We're ahead of all the ninjas. Oh no, we missed the one. Nice. Come on. Big PB. There we go. Alright, small PB. I beat all the ninjas though, so that's good. Top 4,000. Easy money. Easy. That's the start you want. We're at worst tied with the best people. No. No. We have failed. Good. No, no. Slow start. Okay. Can have a slow start though. Our PB's not very good. Get me over here. Yes. No, dude. Now I gotta wait for an hour. That's so sad. Okay, I don't want to finish this. Yep. Yep, yep. Sorry about that. Okay. Oh, wow. I really missed that jump. Thought I got that. Can you not jump that high? I mean, I know you can't. Just garbage. No. No. It's okay. PB sucks. No way! Am I not killing this Goombud? Okay, there we go. I missed my PB. Good. I mean, I don't care about the start. It's really not that important. My PB is absolute garbage anyway. Dealing with this thwomp is annoying. No! Don't hit me! Okay, we're good. Yes! No! The bullet bill from below? Are you kidding me? The bullet bill was still there? That's what killed me? What an insane thing to kill me. That's not how you do the beginning. No. No, there's a Goombud here. I can't win with that. Good. There we go. That's gotta be a PB. I played it safe at the end, but... If this is not a PB, I'm going to explode! We're grabbing the Yoshi. We're playing it safe. Because I want a PB. I didn't even PB. Oh, I'm gonna go crazy. Alright, I gotta end stream. We'll do one more PB, then I'll end stream. That's the plan. Oh, it was a PB. Hey, PB. Alright, we're gonna get top 4,000, and then we'll call it. Nice. No. Yoshi, I swear to God, if you don't come back right now. Give me this PB. Yoshi man. Oh, I'm going to explode. I'm going to eat this mic right now. I'm throwing the ending every time. Big choke sandwich at the end. It's okay. I'll just PB right now. We'll end the stream. Everything will be chill. Alright, this run. Right here. This is the PB. Easy PB. Easy PB. Right now. It's coming. No! That piranha plant throws fire. What a meanie. He took away what I said was gonna happen. Hey, I got the best start possible. Okay, that wasn't so smooth. Oh, but this is smooth. Oh, this is really smooth once I kill this thing. I'm gonna let this guy come down. Look at that, adjusting to what I'm supposed to do in the moment. These piranha plants and hammer bros are quite annoying. Okay, can I please kill these guys for the first time? Yes! There we go. Sub 50. Easy money. We're gonna call it a day. Let's see what number we are in the world. Top 3,500? Top 3,800? Top 3,000 almost. Nice. Well, we'll call it there. We'll play more Mario and things later. Goodbye.